Hello, everyone. My name is Rayees Pasha. Today's topic is going to be a little different. Typically, we do panel discussions or feature overviews on use cases, things like that. Uh, but since we're relatively new in the year, so we figured we could talk about the roadmap of what we plan to do for the rest of the year. So that's why the webinar's theme is what's coming up in Rising Wave 2026 roadmap. And also, as you can see at the bottom, um, we are trying to expand sort of in a way like streaming is still our first love and our core competency, but we've added Iceberg and agents as sort of new areas that we want to sort of expand horizon for our product for in 2026. First, a quick intro for those who don't know me. I'm Rayees Pasha. I lead the product team at RisingWave Labs. Uh, my expertise is primarily in the areas of database management and stream processing. Mostly I've been around data infra products all my life. I started out as an engineer working on a database optimizer at Hewlett Packard for a product called Nonstop SQL. And then I moved to product management roles at different companies, mostly dealing with databases, big data technologies, um, eh, you know. And in a way, Rising Wave is sort of a full circle moment for me because I started out my career as a engineer for like a SQL database. Now, obviously, Rising Wave is a SQL database, but in with a twist that it is a streaming database. So, in terms of the agenda for today, I want to do a quick intro to Rising Wave for those who are not who are brand new to Rising Wave as a product. And then I want to talk a little bit about the 2025 feature deliverables. So it's sort of a look back at what we delivered, some key features, and then look at the feature focus areas for 2026. Because um, as part of the roadmap, I want to focus on the themes we are building on, right? Rather than go through a feature list in a disjointed fashion, I figured giving you a sense of what areas are of importance for us from a product perspective. That'll make it more cohesive. And then we'll also look at the feature request list, and then finally any questions you have, uh, please add them to this to the at the bottom of the in the chat window. Okay, so what is Rising Wave, right? Like this is a question for folks who haven't heard of Rising Wave before or are brand new to our system. So the way we position Rising Wave is basically a streaming database, distributed streaming database. Now we started out as a stream processor where our core competency is how do you process the data that's in motion, right? If you have data coming in from event streams like Kafka, Pulsar, or from CDC sources, how do you take action on the data as it is being transported? Like how do you ingest, process so that if you have data that has short shelf life, how do you process it and then take action on it, right? So that was sort of the core thesis behind our product. From that perspective, we're streaming first. But having said that, we are not just a compute engine like Flink or Spark Streaming sort of model. We also have a storage layer built in. So that's why we call it a streaming database. So as the data comes in, you ingest and we process, and we have a built-in storage layer to store the results of the computation so that either you can use Rising Wave as just a stream processor and then sync the results to a downstream system for you to serve, or you can use Rising Wave as a full-fledged database and serve the data as well, right? So from that perspective, it's a it does both all the it possesses all the capabilities of a modern data platform. Um, and from a data model perspective, the reason why we say it's a database is the primary API we um, we support is SQL. Like although we have UDF and other support, but most of the work you do is based on SQL, and the data model is very tabular in nature. Like it's more like a traditional relational database, and basically from a data model perspective, each stream can be thought of as like a base table in a traditional database. You can join just like you join the tables, you can join the streams, you can perform aggregations, you can do filtering based on SQL predicates. All of the things that you know that you do as a Postgres or any other relational database user, you can bring just those skills and still be able to do stream processing, right? Um, and one thing I wanted to also highlight is our support for Iceberg, because the built-in storage engine we have is our own. It's called Hammock. It's a row store. It's built for high velocity data. If you have like a really low, ultra low latency use cases, it's a great fit, right? But on the other hand, you want to keep the data in an open format, like Iceberg, like an open table format. You have the choice. So from that perspective, you can natively create Iceberg tables. These are completely managed by RisingWave as a system, right? All of the catalog management, compaction, all the services are provided out of the box, and that could be your avenue to perform lake analytics, right? So where you don't need another system to do the management of those tables. So so that's a quick introduction on what RisingWave is. Let's look at some key things we delivered in 2025, because what we do in 2026 is sort of the continuation of that, right? It's not like we're not departing in a big way from what we did, so it kind of provides continuity. The first thing I want to start with is what we call RisingWave Open Lake, basically, which is our Iceberg support. So our journey with Iceberg started as more like a source and a sink, right? Our customers were requesting support to ingest data from Iceberg as well as write to Iceberg. So that's where we started. And then what happened is, as we wrote to Iceberg tables, since RisingWave was in the right path, right? All the data flows through RisingWave and then you write. There was sort of a issue with consistency and coordination in terms of system load, because when you write to a downstream system, the system is not aware of the speed at which the data is flowing through. So it caused some issues. So we started building our own Iceberg table maintenance features slowly. And over time, we have built it in the last couple of years. And now we have comprehensive data management for all of the Iceberg tables. As you can see, we do automatic compaction. In fact, our team is one of the core contributors to Apache Iceberg REST. Um, you know, uh, uh, all the enhancements that are coming in there. We also support catalog hosting, variety of catalogs, REST-based catalog, or, Glue, or Hive-based catalog, all those are supported. We support batch and streaming ingestion, so that for an Iceberg user, you don't have to rely on only batch uploads, but if you have streaming use cases, RisingWave can provide and do the table maintenance automatically. We also support the incremental materialize use, which are one of the core features for stream processing jobs that are available on RisingWave tables, are now available for Iceberg tables also. So you can create an MV on Iceberg tables and get the full benefit of the ultra low, low latency issues. And this product is available both, as an open source edition, so you don't have to have a license, or you can use the fully managed service that we offer as a commercial offering, right? And then in terms of interoperability, as the tables that are managed by RisingWave or can be used with any query engine of your choice, right? We have tested it against DuckDB, ClickHouse, Snowflake. Any of those should work just fine. Okay. I'm gonna go a little bit deeper into the compaction service because it's very important. That's sort of the main uh, core part of it, because as a streaming workloads, you see that as new data comes in, it creates a lot of small files. So how do you handle those small files is a hard problem. And for this, we had to build in our own Rust-based compaction service. Um, and we used data fusion for this to do the high performance processing. And there's a lot of continuous optimizations that have to happen to handle small files in the background. So there's a lot of work we have put in. Another key area is how to handle deletes, right? So how do you merge deletes so that you can support both positional and equality deletions? And especially a lot of the workloads we see are very write heavy, right? So uh, we've had we've added some optimizations to make sure that from a user perspective, no matter if it's merge and read or copy and write, whatever the update model is, both should be, are supported and the data sets are ready for engines of whatever engine of choice that you have for querying. And then obviously it's fully open source. Even though we build this service, for our own use, but we don't require any premium license if you want to try on your own. Another thing I want to highlight is Nimtable. This is a lightweight control plane we built for Iceberg, not just for our Iceberg service, but any any Iceberg service that you can use to monitor your Iceberg tables, look at the metadata, look at sample data, do table maintenance. Like for example, if you want to do compaction, basically schedule jobs, do some analysis, all of those operations sort of things that you can do it using this. Again, this is an open source project, doesn't require a license. So you can control multiple clusters using this product. Okay, switching gears, I want to talk about a product that we introduced in the fall of last year called RisingWave Ultra. This is a performance focused product, right? We build this based on some customer requests where we had some extremely low latency use cases that required us to extend our product capabilities in terms of running it in with ultra low latency requirements. Like for example, if you have complex pipeline and a lot of data coming in, and you still want under 100 millisecond data freshness guarantees. That's a very tough ask, right? So that required integrating best practices, applying performance optimizations, all within the same product. We're not trying to create a new product, right? So that outcome, we called it RisingWave Ultra, and we have a couple of customers using it from ensuring that the same binary is used, but with certain different settings to allow certain those are extremely low latency use cases. And then one of the things that I wanted to highlight is the locality backfilling. This is another key feature that was introduced towards the end of last year. So a locality backfill addresses a hard problem, especially for like backfilling is the process of reprocessing the data, right? Especially you may need to do that when you are creating a new MB or when you are trying to address a data quality issue or you added new data. For any of the reasons, it's very common for our users to run backfills, right? Which means you are bringing in all of the historical data through the MV and reprocessing it, which typically takes a lot of effort, a lot of compute resources, and can have performance impact, right? There we have added this feature called locality backfilling to preserve key ordering, to avoid random IO, which can really bring down the performance. In a way, this allows you to be selective about applying the same partitioning scheme from your upstream datasets onto RisingWave. That way, you are getting most out of utilization of the resources in the cluster. And where this is useful is if your MVs have multi-way joins or you have high cardinality group by basically any big memory operators, right? There typically this would be problem because your memory is constrained on the clusters. No matter how large a cluster is, you'll still run into memory constraints. So this feature allows you to use the memory very intelligently so that you can load data much faster, right? In terms of performance, we have seen really remarkable performance across the board. And we tried to do it on a TPCH benchmark on a 2 gig memory earlier before the locality backfill. A query would fail. In this particular case, it passed within 7 minutes, right? Dramatically. In another way to measure it is the cache miss ratio, right? The lower the cache miss ratio, the better it is, right? So if you have a 100% cache hit, which means the remote IO is almost eliminated, which is what we saw with locality backfilling, right? So yeah, this is another feature that we feel is very useful for a lot of the users. And then last thing I wanted to talk about in the 2025, uh, features we delivered is related to the AI features, right? This is a new area we kind of explored. We started with version 2.5, which was released, if I'm not mistaken, late summer, around July, August timeframe. We added like three different features. One is OpenAI and embedding service. We supported native vector type and also, uh, sorry, HNSW indexes support, which are useful for approximate neighbor problem for high dimensional data especially when you have um, high density vector data. How do you navigate that? That's useful. The reason I put together all these features together is because they are trying to address the same problem, right? If you're trying to build AI features, embedding, traditional stack would, especially for real-time AI services, you would have to have multiple uh, services together as part of the stack, right? So you typically start with a streaming service. You have to have an embedding API service that is separately hosted. And then to store the embeddings, you need a vector database, which is another separate system. And then obviously you have the application layer that has to interact with all this. This creates too many things to come together. What we did was with these features, we collapsed that into a single system, right? Now you can do streaming ingest directly with RisingWave. You can create the SQL embeddings in SQL directly. And then you can use the indexes for vector search and indexes, and then store those embeddings directly as native vector types. So in a way, you have solved the problem of literally 3 or 4 systems into one single system, right? Which means you have less infrastructure to manage. Obviously, your time to production is really fast because you don't have to manage multiple systems, and your low latency, uh, all the performance gains you get from RisingWave are still there. This is not a different system. This is still uses the same incremental processing model. All of the benefits of RisingWave are baked into this architecture. Just to emphasize the key benefits. Obviously, it's still SQL native, which means you don't have to write Python glue code to bring the cross-hop coordination within these services. You don't have to host a separate UDF server because we have embedded UDF capability so that any user-defined functions you run are run in line with the code as part of RisingWave. And then you also don't need external embedding service because that OpenAI's embedding service is a remote call you can make. We also made sure that our vector support is PG vector compatible. So if you're coming from a Postgres database who are Postgres users, it is an easy migration path. It supports the vector end type. It supports some of the operators, for example, to calculate the distance between vectors. And as I said, it's still embedding streaming first, right? So we are not moving away to a batch model with this. It still uses the same engine underneath. So embeddings are created as the data arrives. So there's no on-demand. Uh, you have to run something. It is automatically done, and the indexes are automatically updated just as they would with streaming workloads. And at the end of the day, you basically are replacing a bunch of things, as I said, through a single unified platform. And typical use cases we see where this is come into picture is enhancing RAG pipelines, right? So if you are ingesting whole bunch of documents, you want to generate embeddings through MVs, this is the excellent use case, right? So you don't have to run some scheduled job. You just feed the keep reading those, ingesting those documents. The embeddings automatically are generated, and that makes your system more intelligent in terms of recognizing tokens, and it's very context aware in that sense. Now, semantic search is another use case that we have seen with some customers, where using natural language to be able to do semantic search and figure out based on, if they have uh, use cases that require them to um, match queries based on similarity. Those are very well handled because of HNSW indexes for fast retrieval of the nearest neighbor, right? Those are some of the use cases we have seen. And in general, the where we are seeing these get adopted are in recommendation engines, on some of the in marketing use cases, for example, we're moving from a more historical batch model to live data in terms of product recommendations, recommendations for other reasons. That's where we, our customers are using these features. Excuse me. Now, looking ahead to 2026, right? So I before I go into the roadmap, I want to talk about the feature areas that we are looking at, right? So instead of going through or rattling off a whole bunch of features, I want to see what are the key areas that we are looking at to expand, right? One, we want to unify the streaming and lakehouse area, which kind of has been our focus for the last year or more with our work on Iceberg and all. That'll continue. That'll continue in three different areas. One is to improve our abilities in terms of running batch queries or data lakes, right? So that's a key area that we feel that expands the analytics surface so that you don't use RisingWave just as a stream processing system, but as a unified platform for both processing as well as serving. So from a batch query or data lakes, what we mean is we want to give users ability to query Iceberg or Parquet data directly from the object storage without actually storing the data in RisingWave. So you don't need RisingWave storage, native storage. Also, you don't need a separate data warehouse to do this. So in a way, bringing the unified model together. And then next is support for modern data types. I know so far we have supported all of the base data types. We also have some composite data types to store data with which is more dynamic or schema flexible. With this year, we're going to be focusing support for native geospatial data types. These are very important for location-aware workloads. So we have some customers who use a lot of geographical data, landlord functions, and all that. So we do have some support. We're going to extend it and add like real native support for geospatial types. This also will help us with spatial indexing, queries on geospecific data. Second thing is also UUID support. This has been a long requested feature from some of our customers, especially for if you have modern application schemas, this becomes important. And also, if users are migrating from Postgres where there's already support, this usually becomes an issue, a sort of a friction point. So we want to remove that so that we are much more easily embedded with the wider Postgres ecosystem. And then the last thing we want to do on the analytics side is to enhance our analytical query service. So the current service we have is built on our own Hammock engine. It uses our own native batch engine, right? And by design, it is not built for OLAP queries because of the fact that our primary focus is on the stream processing side. And we noticed that with data fusion, we could do much better. So we have adopted data fusion as our query service. The first version of that is coming in 2.8, which should be releasing fairly soon. We have done some benchmarking, and the results have been very promising. So we'll continue to invest into that so that you can use RisingWave for faster OLAP queries. Um, our uh, our position is not that we're going to become an OLAP vendor, right? So this OLAP services that are dedicated to those workloads. But if you have some queries where you have already pre-computed the results, and if you want to use RisingWave without having to bring in another system, this would be a very good option, right? So that's kind of the model we're going with. A lot of the focus for us in this would be to tackle large scans, especially with um, you know data coming from Iceberg. You typically have vast amounts of data. How to handle large scans, aggregations. That will be the focus of our um, efforts in this area. So in general, to wrap up, in terms of the impact we see, again, our goal is to build a single platform that does both real time and historical, and basically users less reasons to bring in new systems into their data infra stack. Now, next, moving to the next theme we have, one is the first one was about analytics and expanding. The second is to improve enterprise platform, governance and all those things that are required to run RisingWave at scale in production, right? So one of the things we are doing is to add more catalog integration. We already have Hive, Iceberg, Glue ecosystem very well integrated. We will enhance on that as new centralized metadata management systems come in. We plan to test and provide much deeper integration with them. The idea is to provide more easy data governance so that it's not a surface level integration, but much more deeper integration into the product as we become more like a vendor. The second area is the what I call one-click observability. Right now, when you deploy RisingWave, if you're using RisingWave Cloud, great, because you get a lot of the monitoring tools, deep integration into production visibility. But if you're a on-prem user, it's still a little bit hard because the tooling is not standard. You have a different there's a lot more effort required on the customer side, and we are trying to remove that by enhancing RisingWave Console, which is a product that we use, and we are adding capabilities to do a one-click deployment so that the deployment as well as the monitoring stack is part of the installation itself, so that you don't have to have separate things, add-on things that customer has to do it for production workloads. Out of the box metrics, logs, traces will be provided so that user doesn't have to generate them on demand. Like if they have an issue, they can just click a button and then in the back end, the necessary logs are automatically generated and ready to be shared with us, for example, for faster debugging and visibility, right? So the goal is to reduce the operational overhead when running RisingWave in production. The last thing is the multi-tenancy, right? As we have seen with customers, they start with a single use case and then they add more and more use cases. So how do we manage workload so that not only we are performing at scale in a performant manner, but also we're able to do it in a cost-effective manner, right? So which means stronger tenant isolation, providing users with more tools to attach SLOs, like, in terms of service level guarantees for a critical workload versus workloads that can live with higher latency, right? So all those capabilities we're building into the platform. And then next, I want to talk about what we call building more autonomous features. Like we want to provide capabilities to the customer to having to reduce the burden on the operational side where the human involvement is required. For example, scaling, auto scaling. Right now, what we support is what's called adaptive scaling, where a user has to take action to scale the compute based on their traffic, right? Now we want to move away from that to a more API-driven model where compute scaling can happen through control plane. You can have a reactive scaling based on traffic, for example, based on predefined metrics on CPU utilization, memory, or based on some workload signals. Automatically, the cluster will scale up as well as scale down as needed to make sure that the cost efficiency and performance, those trade-offs are well maintained, right, without manual intervention. The second thing is another key thing that we see, which always is brought up, is the materialized view maintenance. Materialized views are streaming live jobs, so they do not, right now, we don't allow modifications to that. So if you need to backfill or change, you'll have to recreate, rebuild everything. Now, we have added a few things to improve the performance of the rebuilds, like as you saw with the locality backfill, but it's still a problem, right? So we want to move away from this model where you can um, modify the MV while it's still running, right? So that requires some work in terms of incremental state migration. For example, if you already have state built in for an MV, if there's only uh, a small part of the state that needs to be updated, for example, if you want to update the historical state for a portion of MV, like for example, if you say, "Hey, I only care about the state for the last 1 week, while anything before that I want to retain as is." So those sort of capabilities we are looking into, and that'll be another big area of focus for us this year. And then the last thing is LLM based database tuning. So we feel like LLMs have come a long way in the last year and a half, right? We internally we use ourselves for troubleshooting, debugging. You've seen, if you are part of our Slack community, you see Run LLM, which is a bot that does a good job of answering simple questions. Now we're going to try to incorporate that into the product so that users can do it in the same interface rather than having to go and ask that question to the LLM separately. So that's another area that we're going to invest into to improve basically provide more autonomy for the user when it comes to running RisingWave. And then the last area I want to talk about is on the data and more on the new real-time capabilities, what we can unlock new features. One, as I mentioned, in 2025, we started with the vector data, right? We added a few features. So that's another area we will continue to invest in, right? We added some native vector search capability that we added. We were going to enhance that, both in terms of performance. We're going to enhance in terms of the um, uh, improving the RAG pipelines, in terms of maintenance of those pipelines, better visibility into their performance. All those capabilities we are looking at in 2026 as well. And data lake governance, that's another area, as I mentioned. As we provide support for some of the catalogs, how to have stronger controls on metadata. So that right now, um, some of the catalogs that are hosted outside, we don't have control over that. So how do you ensure RBAC over that so that any outside changes do not impact the Iceberg tables managed by RisingWave, right? So those are some of the things we are looking at. And then the last thing is CEP. This is an area where we already have some complex event processing. We have some capabilities already built in. So in terms of detecting patterns, correlations through our built-in library. So we are going to add additional capabilities in terms of adding more functions so that if you have, instead of having to write programmatic UDFs to replicate, you can use these built-in functions for some common use cases. So that's another area we are going to like, for example, temporal windowing, which allows you to have certain guarantees in terms of in what order the data would come, correlation of data across streams, pattern matching for beyond the fuzzy search, right? Something intelligent pattern matching. Those are all things we are looking at in terms of the CEP feature areas. Okay, so now the next two that I'm going to talk about in terms of the areas are a little bit outside the product of the core product. So in 2025, we delivered a Model Context Protocol server, MCP server for RisingWave. So basically this is a common path that a lot of the vendors have taken where they have their own MCP server to allow users to interact with the system in a natural language, um, primarily to allow coding agents, other AI agents to talk to RisingWave, and so that you can take advantage of all the automation, right? That's happening with the co-pilots and all that. So in phase one, we delivered the core MCP server that does a basic job of schema and job introspection and is able to monitor the cluster. We are planning to expand that in first half and second half, where we are looking at how we can automate the DDL creation, DML creation from a natural language uh, to a full-fledged natural automation that users can build. Also, streaming job lifecycle. Like if you have an MV, if you want to make a lifecycle management of backfilling, all that, how do we do that and teach basically MCP server to convert the natural language to the language to the SQL that RisingWave understands. Also understand from a diagnostics perspective, if you feed an explain plan to how to decipher the plan for a like especially if you run into a performance issue, allowing some sort of a basic diagnostics, right? That's one of the things. And then the last phase we say is more like advanced optimizations, auto tuning, for example, the system where it learns based on cluster utilization and make recommendations in terms of scaling the cluster or setting the parallelism. Those kind of things, more advanced ones, we want to take up in second half from a MCP server perspective. Okay, and then the last part, last area that we want to focus on, which I think is should be no surprise for others as well. A lot of the products are building coding agents. And in that sense, we're also looking at adding what we call RisingWave AI agent. And we're going through some initial work to add what skills make sense for streaming workflows, right? So I know you could have a coding agent for general SQL or database workflows, but in our case, we want to teach the agent specific issues that a user would encounter with streaming workloads. Like, for example, when to detect that there is a particular streaming job is not performing well. Is it because of the barrier latency or is it because some data quality issue? How to address that? Right. So those are kind of the common problems that users will run into, and how does the agent help so that users can more adopt a self-service model, so they can try to get help on their own with the agent as opposed or use the agent to do tasks that they would rather automate as much as possible, right? So our goal for agent skills is our approach to agent skills is again three-phase approach. Right now we're working on more the foundational aspect, right? Document all the agent skills in a standard file, which requires basically review of query, schema introspection, basic diagnostics from Prometheus data, and try to make sense of what's happening on the cluster. Um, Use basically natural language, use MCP to do the conversion, and provide those capabilities. And a lot of this is happening internally with our internal teams first to make sure the agents not are giving the right information. They're not they are good enough for users to try, right? So once we are get to a phase where it is good enough, then we will roll it out. And after that, the expansion phase comes in where MV maintenance, observability, performance tuning, all the things that require more higher order of expertise will be baked into the product, right? And then obviously um, some workloads like vector or AI workloads require more advanced capabilities beyond typical streaming workloads. So those are all will be taken into consideration. And then as we build in the final phase, we'll see how not just a single, like for the first part, we are talking about only a single skill, right? Like we're talking about optimization for a particular query or a particular schema design or a diagnostic for an issue, right? Now, having multiple skills, like for example, the entire workload review, right? That kind of capabilities that can learn from previous issues in the cluster. It's almost like a parallel agent that's running, long learning agent that has a much longer context window. That's our end goal by end of the year, so that you basically get a co-pilot for a data engineer alongside, who can really offload a lot of the manual tasks or simple tasks to this agent as your co-pilot. That's sort of the vision we have. Um, so basically, I mean, this kind of summarizes what I already explained. So basically, agent will operate like you have a RisingWave expert on your team, right? Like in a way, this model of a pair programming, like you used to have pair programming, now you have data engineering, where the agent kind of takes a lot of the manual grunt work from the engineer. So we see at least three different agents. One is a troubleshooting agent that does automatically diagnose issues continuously and does the root cause analysis. There'll be an optimization agent who will analyze your pipeline and identify, focused on just the performance and the cost aspect of your cluster. And then the self-service agent is more like your help. Like if you have questions about documentation, rather than read the documentation and figure out an answer, you can just ask question and then wait. And also, if you have support issues, this will be your first level of support, sort of, right? That's the vision we have from an agent's perspective. So, okay, I know we have 15 minutes. I'm just gonna quickly. I have only two more slides. Um, so these two slides are more about what we are, in what order the features will be delivered in H1, in first half of this year and second half this year. Now, obviously, the ones in the first half are already in progress, right? They're being worked on in some fashion. The ones in second are a little bit further away. So, the more design things are happening. But for the most of these features I've covered in one way or the other in the previous slide. So we'll just include it here as part of the slide so that it's all together. I just want to see if there is anything specific I missed. One thing I want to call out is what's called BYOK enhancement. So this is a feature basically which brings parity to our RisingWave Cloud sort of deployment on-prem, right? So that if you want an air gap deployment, but you want all of the benefits of a RisingWave Cloud deployments managed service, we are trying to do that, right? So that is it's not a core kernel feature, it's more a service feature. But I think that's going to be very useful for some users uh, who cannot use RisingWave Cloud but want to have the same functionality and capabilities in a in a on-prem environment. And then on the second, I think CI/CD integration, we have a loose integration at this point with some tooling. We are going to tighten it up in the second half of the second year, so that um, from a user perspective, you don't have to build those integrations yourself. Out of the product, it'll come. So that's another big area of product we're going to focus on second half. So let me pause here and see if there are any questions. Yeah, so there's a question, is it possible to get this presentation? Sure, of course. All right, let me see. Do you see any questions, Yona?
Yes, there is a question in the Q&A tab.
Yeah, the question from Jordan. How do you see Iceberg fitting into RisingWave down the road? For some customers, will it fully replace Hammock as a data store, or are there limitations to using Iceberg as storage layer that mean Hammock will still have place running large DAGs and stuff? Okay, great question, Jordan. So I do see place for both of them, right? Because Hammock is built for streaming workloads, high velocity data. There's a lot of, if you have data that is coming in at a high velocity, it's sort of an anti-pattern for Iceberg, right? Iceberg is columnar, and if there is too many small files, you pay the price in terms of compaction, in terms of what the query read time, right? So I do feel like um, Hammock will still be there for use cases for the long term, actually. But it'll be a more even split. Right now, we have customers who use Hammock for serving, which is again an anti-pattern, right? Like it's a row-oriented format, not built for um, OLAP style querying. So I think it's more uh, horses for courses sort of approach. So which you'll that'll uh, take effect over the 2026.
And two more questions in chat.
Okay, let me see. Does Rising provide professional services like education services for teams, planning using it? So we do not have we education services as such to teach. To be honest, we can. If you have questions, obviously, I would encourage you to join our Slack community and ask questions. And we're pretty active there. Like our actual engineers go answer the questions right there. We do not, as such, we don't have a structured education program. Now, in terms of professional services, for example, if you have a requirement to build something, right, where you want sort of like a forward deployed engineer, you require our engineer to be available to help you, um, then we can talk about that. That could be something. But from a pure education services perspective, we are an open source project, so pretty much all the information is out in the open. So from that perspective, it's more about leveraging those resources and asking us questions, which we answer for free in our community Slack. What are the plans relating to DBT integration? What are the plans to relating to DBT integration support, ensuring parity so that rising wave features can be fully utilized? This is again a good question. We are we have a DBT adapter that is certified. It's a core adapter. It's not certified against the cloud, right? DBT cloud. So some features may be an issue, but our goal has been to keep the parity as much as possible, right? Whenever users come ask for certain things, we enhance that adapter, and it's a priority for us. And we see that two-thirds of our customers use DBT, so this is very important for us. So my suggestion is, if you see something where you see unsupported feature, please do let us know, and we're happy to enhance it. Another question from Jordan: why isn't locality backfilling on by default? Are there cases where this is not a good idea to enable it? Again, good question. So it's a new feature. That's why it is not on by default. One thing is, it's also a premium feature, right? So the reason why it's not on default is because this may not be needed for smaller workloads, right? If you don't have too much data, then it's not required. Then you don't run into issues with it, right? With the performance of the backfills. So in a way, it's not for everyone. That's why we tagged it as a performance feature, as a premium feature. So if you make it default, then it means we require a license for you, right? But if you're a cloud customer, it is on by default. So it's not, you don't need to turn on anything. So, but in terms of the um, is it a bad idea to enable it for any cases? No, it doesn't hurt. There's no downside to it. Okay, let me see if there are any other questions. I see one more question popped up. Are there any plans on reviewing resource limitations put on enterprise license self-hosted clusters? So, if you're asking about the four core limit, there are no plans to review that, because we feel the four core limit is sufficient for trying and for dev environments. Um, Anything beyond that would typically mean a production deployment. And so from that perspective, we obviously want a license to support you in a production environment. So that's kind of the rationale behind it. But if you have a use case where you feel you're running into limits with 4 cores and you want a temporary license, we're happy to do that. And we have given that to a lot of customers, users. So we don't worry about that. But to remove blanket, you know, limit is not on is not on the cards. Oh, resource. Okay, so your question is in regards to the limitation and put on resource usage. Um, I would like to understand better where the resource limit is coming in, limitation, because if you have license, uh, yeah, if you can send me a little bit more context uh, through email, I can answer that question. Because if it is related to degree of parallelism or something, we can discuss how that is adversely putting limits on resource usage. Otherwise, I'm a little bit confused on the question. Please reach out, Oliver. Okay, thank you. All right. Let's see, a couple of questions on the QA side. Okay, question from James. From what I gleaned from the scoping, currently creating Iceberg table requires directly creating a table or sync. Could it be possible to make them more directly from RisingWave MetaLab so that both RisingWave tables needing real-time latency downstream batch users from other regions can share the same data and SQL logic just from the same simple DBT model that makes a middle view? Okay. So right now, that's not possible because the rising wave materialized views are a rising wave construct, right? There's no rising wave um, uh, rising wave. There's no iceberg MVs as such. They are in the next spec, but they're not there. So that's why we need this kind of a detour. Um, I can check with engineering if there is another alternate workaround that could possibly satisfy this requirement. But that's the limitation at this point. Did I answer that question, James, or do you have any follow-up? Okay. All right. Any more questions? Okay. If there are no questions, then thank you everyone for attending the webinar, and I will share the slides, and please join our Slack community and let us know if you have any questions. And that's the best way to interact with us as a community. Okay. Thank you.